Hallå eller! Today it's time to go through week 5 of CS50, and today it's the project speller. This project is basically you have a dictionary. I have a text I want to test and see where I spell bad, and that's basically it. So let's just show it off. Here in the terminal you can see I use the small dictionary which I have made here. Hello, I am a bad coder. And I use this text here. Hello, I am good coder. We run it, and then we see I have 3 misspelled words. Exactly like it says. Hello is misspelled, bud is misspelled, and coder is misspelled. And I have, so here it says 3 misspelled. There are 6 words in the dictionary, 6 words in the text. And then it's time stuff. So that's the basic example. I can do it with a larger text. So let's see here. I use the whole dictionary now, which is one. I don't know if it's the whole dictionary, but it's a lot of words. And I use a longer text. Go through it. So I have 30 misspelled words in this constitution text. It's 143,091 words in the dictionary, 7,073 words in the text. It took me 0.2 seconds to load. Took me 2 seconds in check, and very quick to show size and unload. So it took me a total of 2 seconds, it says. Okay, so let's just explain the program. For this project, or what do we call it? Problem? What do we call it? Problem. No. We, from the start, get some files. We get this here, speller.c, which is basically where you have your main function. And in here, you shouldn't change anything. This is what you get, but you should understand it. You get the module called dictionary.c and the header file to put in the functions. And in the dictionary.c, it was here you were supposed to do all the changes, implement all the functions so this speller.c main function would work. And in the header file you just include some stuff and put in the functions as you should do. So let's start here with dictionary.c. From the beginning we have the nodes and a hash table, and then I have made my own global stuff, but we have a check function that returns true if the word in the text is in the dictionary. Then we have, let's see here, then we have a hash function that puts the word in the dictionary in the hash table. Then we have a load function that takes the dictionary, open the file, and places it. And then I take that word and use the hash function for it. The hash function just get the index in the hash table, where to place it in the hash table. The load function opens the dictionary file, gets each word and places it in the hash table. Then we have the size function, which just how do you call it? If everything goes smoothly, it will return how many words there are. And the final function is to it's to free all the memory that we have used. So let's start with just explaining. Let's get the load one here. You have the dictionary file and you want to open it. So here you use fopen and you want to read it because you don't want to change it. Of course, you always check if you have enough memory. Then you need somewhere to place each word. So you make a while loop, and this while loop here is what does basically all the magic. Each iteration, it will go through the, how can you say it, the whole dictionary until it's the end of file. And every iteration it will place that word. So that's it. It will place every word here at the correct index in the hash table. So first, for each iteration of the while loop, I need to create a new node to store the new dictionary word in the hash table, and each index in the hash table will be a linked list with the first letter of the word. So A will be at position 0, B at 1, and so on. This is where I have the hash function. So first we create a new node, check if it's got memory, of course. I get the index on where it should be placed. So I get the first letter from the word. So let's say if it is, let's see here. So if it's abacus, it will check just the first letter and see, okay, it is at index 0 of my alphabet string in the hash function, and will return the index. So then abacus will be placed in the hash table at index 0 at the beginning of the linked list. So every new node that's been created will be placed at the start of the linked list at the specific index of the hash table. So after abacus, then abacuses will be placed before that, and the abacus behind it, and moving on downward. The next thing here is to copy over the word from the dictionary to the node. Then I first point the new node to the old node, so I will not lose my pointers and lose my old nodes. And I'll make it so it's the head of the address, and then I have some counter here for the amount of words. This is not that important. In the end, I close and I set loaded equals true. This also is a global variable I have used for future stuff. But don't forget to close the file. This here is something I will discuss later. After the loaded function, I moved on to making the check function, which checks if each word is correctly spelled. So if the word is in the hash table or not. If it's not in the hash table, it's not correctly spelled. And I made it very nice and good, and I did not get it to work. Every time the hash table was empty, and I was so confused, and I don't know why. And it was because I just wanted to print out what was in. Oh, I'm not gonna do it again. But this thing here, I just wanted to print out everything from the table. But if I does this with the actual table and not a temporary hash table, I will just remove everything. So I learned that you need to use a temporary hash table to loop through and not delete your old one. So this was a murderer, but finally, after like 2,000 hours, but asking some friends at school, I figured it out. We figured it out. It took a lot of time. It was a stupid mistake, which was annoying because it was so hard to grasp. But the actual problem was because I did everything else correctly. But yeah, let's move on to the check function now. As I said before, it returns true if the word from the text is in the dictionary, else false. So first I get the index when using the hash function. So if letter starts with A, the word starts with A, I will go through the hash table at A position. I will make a copy of the variable, and then I will compare it to I will make a copy of the word so I can make it completely lowercase. And then so I can compare it with the dictionary because everything here is in lowercase. So I wanted to make each word from the text completely lowercase so it's easier to compare. So I made a copy of the word and I made it lowercase. Then I had moved on to actually compare the copy word. So I made a temporary table to not get murdered again. And while it's not at 0, so while it's not at null, so it will loop through until it reaches the end of the linked list. I also needed to make the dictionary word or copy it over for some reason. And like probably didn't need to do this, but it was some problem with the memory or something. But it took some time to figure this out because I couldn't like compare the dictionary word and the text word without copying them to a new variable for some reason because they're constants or yeah. But here in the beginning I also mix the dictionary word into a new I don't need to do the two lower. Here, I just need to copy it over, I guess. Oh yeah, it doesn't make a difference because it's already lower. But yeah, I just make a new variable for the dictionary word. So, and then I compare the dictionary word with the text word. And if they are the same, I free them because don't forget I use malloc, free them, and then I return true. And if they are not the same, I will move on and do the loop again. So go through the whole linked list, and don't forget to free the word each time. And if I go through the whole list and doesn't find that word, it will free the copy word and return false. It's a simple one in theory, but yeah, some small details that's annoying to do. Okay, let's move on. Well, the hash function is pretty self-explanatory, so I don't think I need to explain it. Let's just move on. The next functions is the size function, which is pretty simple. I just made two global variables. The loaded one, so because the thing with size here is that it should return a number of words in the dictionary if loaded, and else 0 if not let loaded. So if everything works in the loaded function, I made the loaded one into true, because it's a function with void, so can't put anything in there. So I make loaded equals true, and I count the words for each iteration of the loop. So that's basically it. So if loaded is true, I return the amount of words, otherwise I return 0. And I have the global ones in the top here. Shoop. So that is the size function, which is basically this, words in dictionary. Then I have the unload function, which unloads the dictionary from memory and returning true if successful. That's false. Maybe here I have some problem. Let's see here. I have a problem here. The else false. Okay. I will fix that later. It shouldn't be that hard. But this one, it works perfectly, and I haven't had any problems. But I just need to add the false thing here. But this function is like, in this function, you want to actually go through each index of the hash table, which is 26, so from A to Z, and for each index you want to use the real table, loop through it, because now you actually want to delete every node, and you made a temporary node to save the node's next address. So you take the next address, you kill the current one, and you take the next address, and you move on right until it's finished. And you do it for each index, and everything, if everything works, to return true. I should use maybe to fix this, I can place something here, like if free table I not equals something, I will return false. That's my theory. Please write in the comment how I should fix it, if there's a better way. Yeah, but yeah, this is the whole program. Why it took me such a long time was because of this part where I deleted the stuff and got so insanely confused. Because I didn't know I would delete everything if I used a real table. But yeah, this was it. So I think I'm actually done with CS50 now, and I'm gonna move on to another course, because I wanted to do CS50 because of C, and now we're gonna move on to Python. Maybe I will continue in the future. I'm actually studying embedded software, embedded programming software. So if we continue and do a lot of Python, which I've actually done before, if you've seen in the channel, I will maybe continue CS50. But now I'll move on into embedded class, or embedded course on Texas University, I think, which is much more focused on what I'm studying for. The CS50 one is just amazing to learn C, and the next course I want to do needs the base knowledge for with C. But yeah, thank you for listening. Have a good day. Subscribe, leave a like. Adios.